Previously, we have considered the path integral for the free particle, and now we will consider the path integral for the simple harmonic oscillator. For free particle, the Lagrangian can be written as the following: 1 over 2m x dot square. Then the Lagrangian equation becomes partial x partial L minus dt d d dt partial x dot partial L is equal to 0. This is called the Lagrangian equation. So that gives mx dot is equal to 0, or x dot is constant. For the harmonic oscillator, the Lagrangian is given by 1 over 2m x dot square minus 1 over 2m omega square x square. So partial x partial L is minus m omega square x, and partial x dot partial L is m x dot. So the Euler-Lagrangian equation becomes minus m omega square x minus mx dot is equal to 0, or mx dot is minus m omega square x. This is known as Hooke's law over elasticity, right? So this m omega square can be put into k, and we have actually x squared here. No, not x. Sorry, I must be confusing this x. So the equation of motion for the harmonic oscillator becomes x dot plus omega square x equal to 0. And if we set x classical t equal to a, x classical t equal to b is equal to 0, maybe not this. So we can expand this axis following formula, classical solution, as a sine omega t minus ta plus b sine omega t minus tb. Then xa becomes b sine omega ta minus tb is minus b sine omega tb minus ta. So b is minus xa over sine omega tb minus ta. Likewise, xb, we can write down xb as a sine omega tb minus ta. That means a is given by xb divided by sine omega tb minus ta. So x classical solution becomes sine omega tb minus ta, xb sine omega t minus ta minus xa sine omega t minus tb. And if we differentiate with respect to t, then x classical dot becomes sine omega tb minus ta, and we have omega xb cosine omega t minus ta minus omega xa cosine omega t minus tb. So if we put them together, the x classical dot square is omega square. We have sine square omega tb minus ta xb square cosine square omega tb minus t. We have to be careful. T minus ta minus 2xa xb cosine omega t minus ta cosine omega t minus tb plus omega square sine square omega tb minus ta xa square cosine square omega t minus tb. Likewise, x classical square is, we have sine square omega tb minus ta xb square sine square omega t minus ta minus twice of xa xb sine omega t minus ta sine omega t minus tb plus sine square omega tb minus ta xa square sine square omega t minus tb. So x classical dot square minus omega square x classical square. This is can be put into the following: omega square sine square omega tb minus ta xb square cosine square omega t minus ta minus sine square omega t minus tb or ta plus xa square cosine square omega t minus tb minus sine square omega t minus tb minus 2xa xp cosine omega t minus ta cosine omega t minus tb minus sine omega t minus ta sine omega t minus tb. And we need to integrate. So we need to integrate ta to tb x classical dot square minus omega square x classical dot dt. Didn't I? What happens? So this TA to TB becomes cosine square omega t minus TB minus sine square omega t minus TB dt is again, we have TA to TB cosine 2 omega t minus TB dt is 2 omega sine 2 omega t minus TB TA TB is minus of 2 omega sine 2 omega TA minus TB is same as 2 omega sine 2 omega TB minus TA is omega cosine omega TB minus TA sine omega TB minus TA. The last integral TA over TB cosine omega t minus TA cosine omega t minus TB minus sine omega t minus TA sine omega t minus TB. You can utilize the addition theorem of cosine, then it becomes TA TB cosine t minus TA plus t minus TB. We have omega dt. So this is TA TB cosine omega 2t minus TA minus TB dt is 2 omega sine omega 2t minus TA minus TB TA TB is 2 omega sine omega TB minus TA minus 2 omega sine omega TA minus TB is nothing but omega sine omega TB minus TA. So this integral TA TB x classical square minus omega square x classical square dt can be put into this together. So omega over sine square omega TB minus TA xb square omega cosine omega t minus TB minus TA sine omega TB minus TA plus omega sine square omega TB minus TA xa square omega cosine omega TB minus TA sine omega TB minus TA minus sine square omega TB minus TA 2xa xb omega, oh, we have omega square. So we have that. So omega square. Omega square omega sine omega tb minus ta. So we can put into them together. This is common factor. We have this, what cancels one of those. So it becomes omega over sine omega tb minus ta xa square plus xb square cosine omega tb minus ta minus 2 xa xb. Semi-close correction is we have 2 m over 2 times omega sine omega tb minus ta xa square xb square cosine omega tb minus ta minus 2xa xb. We can take into account the limit for when omega goes to 0, then harmonic oscillator becomes free particle. We can see that becomes m over 2 omega tb minus ta sine omega tb minus ta 1 over tb minus ta. And when omega becomes 0, this cosine is 1, so this is xb minus xa square, and this goes to 1 as omega goes to 0, so it becomes m over 2 tb minus ta xb minus xa square. So this is same as before. So this is action for the free particle, more like a classical action. Now, so the amplitude actually xbtb xata, it becomes the following: exponential I over h semi-classical action times exponential h over a ta tb, so m delta x square minus m omega square delta x square dt, and this path integral. For classical action for free particle, we know that this exponential h over I ta tb m over 2 delta x square dt, and this path integral, we already have this following result: m over 2 pi I tb minus ta. And so what will be the modification for the path integral? So let's make some transformation. So use ta x tb delta x dot square dt is actually ta dt d delta x dt d delta x dt. We can actually integration by part, t square delta x dt. The first part is 0. So exponential I over h ta tb m over 2 delta x square minus m over 2 omega square delta x square dt is actually h bar over I ta tb m over 2 delta x dt square d square minus omega square delta x dt. Since delta x is 0 at t equal ta, t equal tb, so we can expand delta x t as some Fourier series sine t over n pi t, t equal tb minus ta, and we call this as omega n. Then ta over tb delta x minus dt square d square minus omega square delta x dt. It can be put into nn prime, integration from t an prime sine n pi over t omega n square minus omega square sine t over n prime pi t dt. And so it becomes n prime an prime omega n square minus omega square and 0 to t sine n pi over t sine t over n prime pi t dt. So this sine becomes 1/2 cosine t over n minus n prime pi t minus 1/2 cosine t over n plus n prime pi t. Then this whole integration can be easy to do. Is t over 2 delta n prime. So you can check at home as homework. So it becomes t over 2 omega n square minus omega square an square. And also we can change this delta x t as a over dA1 a over dAn. pi I h epsilon minus half. Times 1 over a. So this becomes n plus 1. The one of the integral, this, m over 2 pi I h epsilon 1 half exponential I 4h over mt lambda n an square tan. Just here lambda n is nothing but omega n square minus omega square is n square pi square over t square minus omega square. So it becomes 2 pi I h by epsilon 1 half square root of 4h pi minus I mt lambda n. So this cancels this. This 2 pi h bar cancels 2. I minus I cancels each other. So it becomes 2 over epsilon t 1 half times n square pi square over t square minus omega square minus 1 half. So xb minus xata is exponential h power over I semi-class correction times to 1 half and n square pi square t square minus omega square minus 1 half and we can put some constant times exponential h power over I semi-classical and 1 minus n square pi square omega square t square minus 1 half. And there is a reason why I'm putting this way, because we can be written as a sine following formula. So z over sine z is actually I equal to n infinite 1 minus n square pi square z square. This is called infinite product. I can show this relationship, but for now you have to believe me. Then we have the following: n equal to 1 to infinite 1 minus t square omega square n square pi square minus 1 half is nothing but omega t over sine omega t over 1 half. So we can say that xbtb xata can be some factor exponential h power over I semi-classical. This will be free ratio, free exponential h power of I, semi-classical. And we set this as a omega t over sine omega t 1/2. Then our formula will look like this: xbtb minus xata is sine omega t of omega t 1/2, and then the next factor is free particle part, tb minus ta, and exponential h power of semi-classical. Semi-classical is written as m omega 2 sine omega tb minus ta xa square plus xb square cosine omega tb minus ta minus 2xa xb. The interesting thing is this whole factor becomes m over 2 pi I h bar tb minus ta as omega goes to 0. So harmonic oscillator, the path integral for the harmonic oscillator becomes that of a free particle, but we can write down this way: m omega 2 pi I h bar sine omega tb minus ta over exponential semi-classical action. Okay, so let's stop for now.